Good morning, afternoon, or evening, depending on when you're working on this. I find myself saying that a lot because the reality is there is not a schedule for you guys, and it's the office hours give a good guideline, but life happens. Some of you guys are working, some of you guys are helping your family out with stuff, so you're getting your work done when you can. So I appreciate that a lot. What we're doing today is, previously we talked about the law of sines, and now we're going to talk about the law of cosines. Now you might be thinking, is there a law of tangents? To my knowledge, no, there's not. So don't be surprised if you don't see another law after this, which is good news. Now, with the law of cosines, right, we're dealing with a triangle ABC, just like with the law of sines, three-sided figure triangle. And just like before as well, right? Angle A is across from side length A. Angle C is across from side length C, and angle B is across from side length B. They all match up. Not sure why this image moved, but anywho. So, regarding this law, we're going to have three different ways to write it. With the law of cosines, there were two ways to write it. There was a way to write it when you're trying to find sides, and there's a way to write it when you're trying to find angles, because you're setting yourself up to do the minimal amount of work, the minimal amount of algebra to solve for those pieces. With the law of cosines, there is not when you're finding sides versus when you're finding angles, there aren't different rules for it, but there are definitely three different ways, because with the law of cosines, there's kind of a focus letter, or I guess you could say there's a focus angle side pair. And the focus is always going to be the one that is unknown. So sometimes side length C will be unknown. Sometimes side length A will be unknown. Maybe angle B is unknown. But anyways, that is the focus of the formula. And the way that that shows up is how we start it. So let's say that we're focusing on trying to find either side length A or angle A. Let's say that we're focused on A first. We'll go in alphabetical order. The law of cosines is the following. A squared equals B squared plus C squared minus 2 times B times C times the cosine of big A. Lots of letters, a lot happening. If you ignore the negative 2 BC times the cosine of A, if you ignore that, you're just left with, well, the Pythagorean theorem if A were the hypotenuse. So there's some familiarity, but there's also some unfamiliarity. Now you might be able to think, okay, well, if I were to start with, let's say we're focused on side length B and angle B. That means I'm going to start with B squared equals, and you might see the pattern here, right? If I'm using and focusing on B, A and C are the other guys. So A squared plus C squared minus 2 times A times C times the cosine of capital letter B, angle B. And then last but not least, when we're focusing on side length C and angle C, it's going to be C squared equals A squared plus B squared minus 2AB times the cosine of capital C. So these three formulas are what give us and can help us find missing side lengths and missing angles. This first video, this lesson today, is going to focus entirely on how to solve for a missing side length. and what that looks like. And then tomorrow, or I guess I should say either Friday or next week, Monday, you will be learning how to find missing angles. So first, it makes sense just to give a couple of examples. Finding a missing side examples. So if we're trying to find a missing side, here are two examples in order to find a missing side. So when I look at my two triangles, let's focus on the left side first. What information do we know? Well, we know that side length B is 21, and I know that side length C is 32, right, because it's across from their letters. And I know that angle A is 40 degrees, but I don't know what side length A is. And that's what I want to solve for. So let's set up our problem using our formula, right? So remember, in this case, if we're trying to solve for A, I should be using this version of my formula. So let's do that. So A squared is equal to, now it's B squared, well B is 21, so 21 squared, plus what's 32, or what's C, well that's 32 squared, minus 2 times, in this case, times B, so that's 21, times C, which is 32, and then that's times the cosine of the angle that we know, or angle A, right, because A, and that is 40 degrees. All right, from here we just plugged it in, and so now we need to literally just solve it and get it to a point where it's A squared equals some number, and we'll take the square root of both sides. So let's keep going. So A squared is equal to, well, 21 squared, we needed to calculate all these things, is 441. 32 squared is 1,024. And then we're going to subtract, well, let me do 2 times 21 times 32. That is 1,344 minus 1,344 times the cosine of 40. And the cosine of 40 is 0.766. So times 0.766. All right, let's do some addition and subtraction and multiplication still. So right now I'm going to add these two together, and then I'm going to multiply these, and then I'm going to, in the next step, subtract those two numbers. So here we are, A squared is equal to 441 plus 1,024. That's equal to 1,465. Now, if we look at 1,344 times 0.766, that is equal to, I'm going to round it. I'm going to try to round to one decimal place just to keep everything neat and ready to go. So 1,000, so this is going to be, and remember it's subtraction, so subtracting 1,029.5. I have my calculator here doing these calculations. I'm not pulling them out of thin air. Now, let's do A squared is equal to 1,465 minus 1,029.5. And that gives us 435.5. Now, what do we do when we have something squared equals a number? How do I get that variable by itself? Well, you take the square root of both sides, and that undoes it over here. So we're just left with A. And if I take the square root of 435.5, I'm left with 20.86863675. We are going to round it to the nearest tenth So 1 decimal place. In that case, we're going to round up to 20.9. That is our solution. So A no longer is a question mark. A equals 20.9, whatever the units of measure is. Now, when I look at that, I think, you know what, that makes sense, because a side length of, or an angle of 40 degrees is probably going to be on the smaller side with respect to the entire triangle. And remember, there's that relationship. The smallest angle is going to be across from the smallest side. The biggest angle is going to be across from the biggest side. So in this case, 40 degrees looks like it's the smallest angle, and it in fact gives us the smallest side. 20.9 is less than 21 by a hair. So let's try that again, right? We've done it once. We've got a rhythm. Let's do it one more time. So here we are with example 2. Let's look at what we are given to start with. Well, we're given, in this case, they're telling us that, right, angle B is across from side length B. So they're saying side length B is 26. Angle A is across from side A. So side length 17 is A, 26 is B. And when it's across from C is the angle that we know of 124 degrees. So what is C? We're trying to find C. When I go back, right, that's referring to this helpful formula. So we are going to use that version of the formula. So it's going to be C equals. So here we go. Let's start. So C squared, oops, I want yellow. So C squared is equal to, right, if I'm referring to C squared, then I'm going to do A and B squared over here. So it's going to be A squared, which we said A is 17, so 17 squared. That was a really bad 2. That was another bad 2, but I'm going to go with it. Plus B squared, which is 26 squared, minus 2 times 17 times 26, right? Because I'm multiplying by those guys. And that's going to be times the cosine of the angle 124 degrees. Sorry, I ran out of room a little bit there. We are just plugging it in and solving for C now, right? Everything over here is known. C is unknown, so we're trying to solve for that. So next step, C squared equals, that was a really bad 2 again, equals. Now we go to our calculator. 17 squared is 289. 26 squared is 676. And then if I'm subtracting 2 times 17 times 26, 2 times 17 times 26 is 884. Times the cosine of 124. And when I do the cosine of 124, remember, make sure you have this in your calculator in degree mode, excuse me. This ends up being negative 0.559. 0.559. Now what that means is if I have a negative here multiplied by a negative here, that means it's going to become a positive. So we need to make sure we identify that in our next step. So we've got C squared equals 289 plus 676 is 965. Now, remember, like I said, it's a negative times a negative, so we're going to be adding whatever that ends up being. 884 times 0.559. That gives me 494.156. So we're going to round up to 0.2. Now we are going to add those together. So that is going to be 965 plus 494.2. That gives me 1,459 point, that looks like a 7, 159.2. Now, exact same situation as the last problem. We are left with c squared equals some number. How do I get c by itself? I need to take the square root of both sides. That gets rid of the squared, and I'm left with c equals the square root of my previous number, 1,459.2, and that gives me 38.199476. So 199 rounds up to a 2, and that is my solution. So here we didn't know what c was, but now we know that c equals 38.2. Does this make sense as an answer, right? Don't necessarily always trust your calculations. In this case, an angle of 124 is definitely going to be bigger than angles A and B. Those are tiny little angles. So that's the biggest angle. Is 38.2, is that a larger side length than 26 and 17? You should be shaking your head yes, whether it is literally or in your mind. But in this case, we are successful in our problem solving for this this situation. So here's the deal. This assignment, you're going to be required to watch this video, take the notes, and then submit those notes back to Moodle, so that I can make sure that you did those, so that you have them for the future on Thursday when you practice this on Delta. And I will give you a Delta example video so that it can guide you, because Delta does not have practice or help videos yet uploaded on their website. So I will give you an example video there. I'll post that as well, and you guys will be in tip-top shape for Thursday. Now, I know that there is a second page to the note sheet, where you're probably wondering, hey, what are we supposed to do with that? Well, hold on to the printed out note sheet, or if you did this on a separate blank sheet because you can't print at home, then what I would ask you to do is save that piece of paper. I know that you've already submitted a picture of the front side, but I would like you to save that paper, save that note sheet, and continue on the next time that we do more notes. And maybe you'll, who knows if you misplace it, but beauty of this is once I post a document, you can always refer back to it and delete it or download it if you need to and print it as necessary. I'm going to sign off now. Thank you guys for your hard work. We're getting there. We're getting close, and then we'll have the summer. So thank you guys. Take care. Ask questions on the Office Hours Google Doc, and I will talk to you then.